Hello chemists, this is Miss Placino and you are watching screencast 1.6 on the structure of the atom. In today's lesson we're going to look at the different subatomic particles that are present in an atom. We're going to talk about some of their general properties, and we're going to discuss how to figure out the number of subatomic particles that are present in an atom. For ado now, I've given you a couple of chemistry riddles, so pause the video and give them a shot. Alright, the first one says, a proton orders the most expensive meal on the menu. The waiter asks, "Are you sure?" The proton says, "I'm positive." A neutron walks into a bar and asks how much it costs for a beer. The bartender says, "For you, no charge." And finally, why don't the other subatomic particles like being around the electrons? Well, it's because they're always so negative. I know. Chemistry puns are so bad, they're actually good. Let's get into some real information about protons, neutrons, and electrons. So we'll start with our protons. The charge of a proton is positive, it's +1. It has a mass of 1 U. And U, or unified mass unit, sometimes called an atomic mass unit, is a measurement for mass or a unit of mass that you might not be familiar with. Protons, neutrons, electrons, they are extremely small, and trying to measure their mass in something like pounds or even grams is going to be highly impractical. A U, unified mass unit, is equal to 1.6605 times 10 to the negative 27th kilograms. So this is an extraordinarily small unit of mass, and we really only use it when we're talking about subatomic particles or individual atoms or molecules. It's really impractical to use AMUs or U's for anything other than those instances. Don't worry too much about what the actual number is. We're not going to really be doing any calculations based on that. Just be aware of the fact that atomic mass units or unified atomic mass units are extremely small. Back to the proton, it is located in the nucleus. Moving on to the neutron. Neutrons are neutral. They have no charge. Like the proton, it has a mass of 1 U. In reality, it's slightly more than a proton, but for our purposes, we're going to treat them as though they have identical masses. And like the proton, it is located in the nucleus. Electron is our last subatomic particle. It has a charge of -1. For our purposes, we're going to assume that it is massless. In reality, it has a teeny tiny mass. It takes like 1,800 electrons or so to equal the mass of 1 proton. So for all practical purposes, we're just going to assume that it has a mass of 0 U. And electrons are found in orbitals or orbits outside of the nucleus. So the nucleus is where our protons and neutrons are contained. And we talked a little bit about the Bohr model of the atom in the previous screencast. This is a topic we will be revisiting next unit. But the general structure is we've got at the center of the atom our nucleus, and that's where we're going to find our protons and neutrons. The electrons are going to exist in orbitals or orbits, which are simply paths that the electrons can move around the nucleus in. According to the Bohr model, or the planetary model, one and the same. The nucleus, like the sun, is fixed at the center. The electrons are like planets, and they're going to rotate or orbit around the nucleus. You've got all the elements on the periodic table, and there's really a ton of information packed into the periodic table, and I want to take just a minute or so to go through it. So here's kind of just like, I'm going to call it an element square for lack of a better name, for carbon. First, I want to talk about the atomic mass, which is this number right here. If you think about the subatomic particles, the only particles that have an appreciable mass are the protons plus the neutrons. So when we're talking about the atomic mass, that's just simply the mass of the atom. Now you might be wondering, well, wait a second, is it possible to have like 0.011 protons or 0.011 neutrons? Why isn't the atomic mass a whole number? And that's an excellent question, but I'm going to put it on hold until the next lesson. If you look at screencast 1.7, we're going to discuss that in more detail. The other number that I want you to be really comfortable with at this point in time is the atomic number, which for carbon is 6. The atomic number is the number of protons that are present in the nucleus, and we say that this identifies the element. What that means is if you have an atom and it has 6 protons in its nucleus, it has to be carbon. It can't be a carbon atom if it has 7 protons in its nucleus. Then by definition, it is nitrogen. So that's all it means when we say identifies the element. We can represent this information in a couple of different ways. So sometimes you might see something written like C12, where we have the elemental symbol, dash, and then the mass. So you see the 12, those are the same. Another way to represent it is this structure here, the same idea, the atomic mass up top, the atomic number in the bottom. The reason you don't need the atomic number, sometimes you might just see it as C12, is because it's carbon, and we know that the atomic number of carbon is 6, so it doesn't really have to be specified. Let's talk a little bit more about the periodic table while you've got it in front of you. I'm going to draw in the staircase, and if you look at your periodic table, you're going to see like a thick black line that separates really the periodic table into two. And that's a good landmark to use to talk about the elements. Metals are to the left of the staircase, so our metallic elements are over here. There's one big exception to that generalization. Hopefully you know that it's hydrogen. Hydrogen is not a metal. Sometimes you'll actually see periodic tables every once in a while that put hydrogen over there next to helium, but that's not how we usually see it, so I'm going to erase it. But just keep in mind that hydrogen is an exception. Even though it's to the left of the staircase, it is not metallic. On the opposite side of the staircase, we have our non-metals, all these, I guess, kind of light blue colored metal elements over here, non-metallic. Please keep in mind that non-metallic doesn't mean not solid. Something like carbon and phosphorus and sulfur, those are all going to be solids at room temperature. Our gases are this last column over here called the noble gases, fluorine and chlorine, nitrogen and oxygen. Everything else actually exists as a solid, or bromine is a liquid at room temperature. And finally, these kind of, I guess, pinkish purple elements, these are called metalloids. Clean this up just a little bit. There we go, get rid of that stuff. Metalloids, sometimes called semimetals, are located above or below the staircase. And in order to be qualified as a metalloid, you have to have two sides touching the staircase. So something like boron has the left and bottom part of the box in contact with the staircase. Carbon would not be classified as a metalloid because it's just touching on this little corner. So carbon, not a metalloid, boron is a metalloid. By looking at this picture, you might see that we've got an exception to this rule as well. And that exception is aluminum. Clean this up. Aluminum, as the color on this periodic table suggests, is a metal. It's shiny. That is a very metallic element. It's just kind of in a bad spot. So keep in mind those two exceptions. Hydrogen is a nonmetal and aluminum is a metal. Don't be fooled by where they are located on the periodic table. Got another little chemistry joke for you, in case you're having trouble seeing it. The red atom says, I'm hit, I've lost an electron. The blue atom asks, are you sure? The red atom now says, I'm positive. Lots and lots of great chemistry humor for you today. If an atom gains or loses an electron, we no longer call it an atom. Instead, we call it an ion, and ions are simply atoms or potentially groups of atoms that are charged. The charge can either be positive or negative because it has either lost or gained electrons. So a little bit more about the terminology of ions. We have cations, and cations are ions with a positive charge. One of the ways I remember it is that there is the letter T in cation. You can think about a plus sign looking like a letter T. In order to become a positively charged ion, the atom has to lose electrons. Protons aren't going anywhere. You can kind of think about them as being stuck in the nucleus. The electrons are the particles that are moving and can be lost or gained. So if an electron or a negatively charged particle is lost, the resulting ion is going to be positive. Metallic elements form cations. Metals tend to lose their electrons for reasons we'll discuss more during Unit 3. So just to show you what I mean, we've got Na, which is sodium. Sodium's on the far left-hand column of the periodic table, which makes it a metal. And if we look at the periodic table, we can see that sodium has an atomic number of 11, so there are 11 protons. And I'm just going to count them real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. So this is neutrally charged. Sodium wants to get rid of that outermost electron. And when that happens, I still have my 11 protons, but now I have only 10 electrons. So if we just do the math, which you probably don't need to do, 11 plus negative 10 equals 1, and that's where that charge comes from. And that's typically where we put the charge. So the way I would write this would be sodium plus. I don't have to write the 1, it's implied. The opposite of cations are anions. Anions, as you might imagine, are ions with negative charge. The way I remember this is I've got two N's in the word anion, and negative starts with an N. Anions, as you might imagine, are formed when electrons are gained. So electrons are negatively charged. When an atom gains electrons, it's gaining negative charges, so we're going to end up with an overall negative charge. And our nonmetals tend to form anions. Here we've got chlorine. I'm not going to go through and count them, but on your periodic table you can see the chlorine has 17 protons in its nucleus. It's got this extra electron thrown in there. You can imagine it was given away by sodium, or chlorine stole it, however you want to think about it. So I now have 18 electrons. Again, we'll do the math, but you probably don't really need to. 17 plus negative 18, because our protons are positive and our electrons are negative, gives us a negative 1. So if we wanted to represent that, we could do that with chlorine minus. All right. So let's talk a little bit more about trying to figure out the number of protons and electrons and neutrons that are going to be present in an atom or ion. So we'll pull up your practice problems. Don't worry, we're not going to go through all of them. So what we've got here are different species, both atoms and ions, and I'm asking you to determine the number of protons, neutrons, electrons, classify that substance, or I should say that species, as either an atom, an anion, or cation, and finally get the element name. Alright, so we'll just do the first one together. F, if you look at your periodic table, its name is fluorine, so I'll just fill that one out first. Also, based on the periodic table, I see that fluorine has an atomic number of 9. We know that that is going to correspond to the number of protons in the nucleus. Fluorine has an atomic mass of 19. I can find the number of neutrons by taking the atomic mass minus atomic number. So in this case, 19 minus 9 gives me 10. I don't see any charge. If I did, there'd be like a little number up here, where I just put that red dot. There's no charge there, so that means that the substance or the species is neutral. So if it's neutral, the number of positive charges must be equal to the number of negative charges, or protons must equal electrons. So we must have a total of 9 electrons as well. And finally, because it is neutral, this would be classified as an atom. Let's make that look like an A. Alright, what I'd like you to do is pause the video and try those next 3. Let's take a look at the next one. We've got O with a charge of -2. Hopefully you know oxygen is represented by the elemental symbol O. It's got that negative charge, so this is definitely an anion. Anion. Spelling is not my strong suit. You can use the periodic table to figure out protons, neutrons, and electrons. Every element, the atom of oxygen, whether it's an ion or not, is going to have 8 protons. Atomic mass of 16, so we must have 8 neutrons. And because of that -2 charge, we're going to take the number of protons, as that would be equal to the number of electrons. If it was neutral, it's -2, so it gained 2 electrons. And this is where a lot of students can kind of get tripped up. So this is a total of 10 electrons. I have to have 2 more negative charges than positive charges. Moving on to the next one, that is cobalt. That +3 in the upper right-hand corner next to the lowercase o makes this a cation. Cobalt always has 27 protons in its nucleus. It's going to have 32 neutrons based on atomic mass minus atomic number. And the number of electrons is going to be a total of 24. Again, protons will equal electrons in an atom, so that starts us off at 27. This is cobalt with a charge of +3, so I must have lost 3 electrons. 27 minus 3 is 24. And last but not least, we'll do magnesium. I don't see any charge with magnesium, so it's safe to assume that it's neutral, making it an atom. And based on what I know in the periodic table, or what I can look up from the periodic table, magnesium has 12 protons, 12 neutrons, and 12 electrons. Just a couple of things before we go and wrap up the lesson. If you've got stuff like this, remember, that's going to represent atomic mass. There are things called isotopes, which we'll discuss more in the next lesson, and they have very specific masses. So that's what that's telling you. Same thing when it's elemental symbol dash number. That is the mass of that specific isotope. And don't forget, these are all of your charges. All right, so just to finish up, conclusion, I'd like you to quickly explain how you find the number of protons, neutrons, and electrons in an atom or ion. This is easily the most important take-home from this lesson. Okay, so with protons, pretty straightforward. Use the periodic table and just look at the atomic number. If it's got 12 protons in its nucleus, it has to be magnesium. It's right there on the table. To find the number of neutrons, take the atomic mass and then subtract the atomic number. Electrons are a little bit more complicated. If you're working with an atom, atoms are neutral, so number of protons will equal number of electrons. Ions, it's more complicated. If you've got a cation, remember a positively charged ion, you're going to take the number of protons and you're going to subtract the charge from it. Cations have lost electrons. If you've got an anion, or a negatively charged ion, you're going to take the charge and you're going to add it to the number of protons, because now the electrons should outnumber the protons. I would really recommend going through and trying a couple more of those practice problems that we just started going over. I know it's not super complicated to figure this stuff out, but just make sure you've got the hang of it, as we're going to be building on this concept more tomorrow.